Welcome back, ladies and gentlemen. This is a lesson on the activity series. Okay, we have two activity series here, activity series of metals, most of the top part here, and then activity series of just the halogens. There's four halogens here. And what this is it's telling us which metal or which halogen is more reactive than the other. On your periodic table, you find that list here as well, activity series. This is used for single replacement reaction. Single replacement reaction. If you recall, single replacement reaction is when A plus this compound B and C is together, and the question we ask is, can A replace B in this compound? Right? A being the metal, it will try to replace the metal part. If A is a non-metal, is a halogen, is going to try to replace the second part, the non-metal part. So if it's more reactive, then B will get kicked out, and then A is now with AC. This is kind of like the home record edition of chemicals. Okay, where A is more reactive, it's going to break up B and C and steal C from B. So B is now all lonely and all sad. So somebody's going to be alone on each side, right? A single replacement reaction, you can have a single element and then a single element on either side. See? So single replacement, how do we use that? So this is the activity series. It tells you here, all replace hydrogen in water and acids. Each replaces metal listed below it. So the higher one, lithium, can replace rubidium, everything below it. But sodium is below, it cannot replace lithium. It cannot replace anybody above it. So if it's not as reactive, it cannot replace. Okay. So sadly here, a couple of the ones on the bottom, all are mostly unreactive as far as replacing each other, replacing other metals in a compound. So gold can't replace nobody. That's why gold is our jewelry. Platinum cannot replace anybody. Platinum is our jewelry, silver. So notice these are our jewelry metals, right? So you don't want those to be reactive. You want those to be very stable. They will not react with many things. They will not react with most things, actually. That's why it's actually good for our skin, good for us to wear on a normal basis. Copper is used in a lot of things like plumbing, right? So it's fairly safe, it's fairly stable, okay? And so you see that it says hydrogen. So hydrogen will fit right here, just like on your list. Okay, just like on your list, hydrogen fits right below lead, but above copper, mercury, silver, platinum, and gold. So these two lists are very close to each other. And if you recall our lab magnesium, we put it in, we put it in magnesium hydrochloric acid. And then this magnesium, notice, magnesium up here, it replaces hydrogen. Yes, above replaces below. So magnesium will kick hydrogen out, so hydrogen gets kicked out. That's the gas that we collected on the test tube, and we burned it, and it made that whoop noise. And then magnesium is now with the chlorine. That magnesium's with the chloride. So here's the new hookup. Here's the new bond between magnesium and chloride because hydrogen got kicked out. Okay. So halogens, there are four halogens here: fluorine, chlorine, bromine, iodine. It's basically fluorine can replace anybody below. Iodine cannot replace any of those. The bottom cannot replace above. That is the key. And that's nicely the same order as on the periodic table. Fluorine is above, chlorine and bromine, iodine. So just remember those in the same order. Okay. Iodine cannot replace fluorine. Iodine cannot replace anybody above. So that's the order of it. So on the next page, you'll see here just a couple practice problems here. So just look. Is calcium. It says for each following pairs of elements, underline the one that would replace. So it would be higher on the activity series. Okay, it will be higher in the activity series. So you look, calcium and tin. Right, look at calcium and tin. Calcium is right here, and tin is down here. Calcium's above, so it will replace. So you'll circle calcium. The one is above, the one higher. Okay. And if you look at bromine and fluorine, remember these are your halogens. These are halogens. So you look on the other list, fluorine, bromine. Just look at the periodic table. Bromine and fluorine. Which one's higher? The answer is fluorine. Very good. Fluorine, so fluorine is higher. Will replace. All right. So take a moment, take a couple minutes, pause the video, take a couple minutes, and do all the way through G here. And then after you come back, I'll walk you through number 2. Okay, just a very short video. So, hey, so that's a lot of direction here. Read it to yourself. I'm not going to bore you and read to you, but here's the gist of this thing. So lithium is a metal. Okay, it will try to replace the other metal, which is iron. So look at your list. Is lithium above iron? So lithium's all the way on top. It's going to replace everybody. Can't replace iron. Iron's all the way down here. So the answer is yes. That means, so remember, first question is lithium above iron? Fe, that means, and the answer is yes. So there is going to be a reaction. There is going to be a reaction, and the reaction will take out iron. Iron is now lonely all by itself, and the lithium now bonded to the nitrate there. And that's the formula, the equation for it. Li is +1, NO3 is -1, so they balance out. Now we have to balance these suckers. No, there's 3 NO3 here, so 3 there. That gives me 3 lithium. I have to put 3 there for 3 lithium. The iron is 1 and 1. That's good. Beautiful. All right. Number B here. We look at gold. Is gold going to replace the hydrogen? So the question is gold above hydrogen? Is gold above hydrogen? So you look here, gold. Gold is all the way down here. Hydrogen is up here. So gold cannot replace hydrogen. So then there's no reaction there. No reaction. Okay. And C, you finally see here, chlorine is a halogen. It's going to try to replace the Br. Okay. Remember, if it's a metal, it's going to replace the first one. If it's a non-metal, it's going to replace the other non-metal. So is chlorine above bromine? Chlorine above bromine. So yes. So is chlorine above bromine? And the answer is yes. So there is a reaction. Yes, so there is a reaction. So Br gets kicked out. Remember, Br by itself is diatomic. So we write Br2 plus K is +1, Cl is -1, so it's just KCl. Don't copy the 2 over because the 2 is because it's diatomic. Now you have to balance there. Put 2 in front of K there. I have 2K, 2Cl now. So 2 in front of KBr to get me 2K, 2Br as well. So 2 of each. So that's really the gist of signal replacement. Signal replacement, you use the activity series here to determine which one is more reactive. If it's more reactive, then it can replace. If it cannot react, is less reactive, it cannot replace, and there is no reaction. So you go ahead and finish these 3 questions, and then think about the activity series, and you should be able to answer these questions conceptually. This is how it's relevant to our lives. It's how activity series play a role of all the metals around us. There's metals around us everywhere. So think about your answers here. Write answers down for each of these. And that's it for this assignment.